Access, May 11, 2024. Improving Access with 3D Printed Tactile Graphics. Michael Cantino.
So my presentation is Improving Access with 3D Printed Tactile Graphics. I did want to include a quick kind of definition for tactile graphics to make sure we're all on the same page. So tactile graphics are images or other graphic content that is presented in a tactile format for readers to explore by touch. I think we'll kind of use that as a working definition today. Hopefully we'll see how this is being applied with 3D printers. There are kind of various methods to do this traditionally. Raised line drawings be the most kind of prevalent, and we'll talk a bit about that as we get started. So a quick introduction first. My name is Michael Cantino. I'm the blind technology specialist for Oregon's public schools. I'm a Braille transcriber certified through the Library of Congress, and I work on a couple NSF projects aimed at improving STEM literacy for Braille readers. So one is Project Inspire, which is primarily focused at K-12 learners and improving, there's my computer trying to update, improving access to STEM Braille for K-12 students. And then Raised Mathematics is a collaboration between Speech Rule Engine, which powers MathJax and Chromebox, and a project called Pretext. And in that project, we are working on automating the production of college-level textbooks, math and science textbooks, into Braille with tactile graphics, which has been super exciting. So I think a lot of what we're going to be talking about today is kind of my experience in creating tactile graphics and tactile art, and kind of how that came to be for me, what I think the benefits are of this approach, and what I think the implications are for the field. So I've been working with students with various disabilities since 2006 in K-12, the public schools, and in higher education. I began transcribing in 2012. And then after a couple of years, 2014, I completed my official literary certification through the Library of Congress. At that same time, right after I got certified, I was trained on creating tactile graphics in Adobe Illustrator, and kind of quickly fell in love with this process. And so I've been doing a lot of work around tactile graphics since then. In 2017, I completed my Library of Congress NEMIS certification course, and I started really kind of specializing in STEM materials. There's a couple images on the screen here of some past work that I did. There's a tactile graphic of a lemur with this nice ring tail. And then there's a tactile graphic of a blue whale. You get kind of a top-down view of the blue whale, and then a close-up of the whale's fluke, the kind of end of its tail. So these images that are on screen would have been embossed on a Braille embosser, and these are kind of what we would traditionally call raised line drawings. These are kind of the most common type of tactile graphic that people are interacting with, or these raised line images, kind of simple 2D images. So my journey from 2D graphics to 3D graphics started when I got my first 3D printer. I was working at Columbia Regional Inclusive Services here in Portland, Oregon. And in 2015, we bought our first 3D printer and did a bit of exploring there about how we could use this with our students. And after some experimentation, I realized that the tactile graphics workflow I had been utilizing to create these raised line drawings, like what we looked at on the previous slide, transferred fairly well to some basic 3D modeling. And so I started to kind of explore, how can I take my workflow I have now and start using that with a 3D printer? And that led to me initially making lots of tactile maps. And then I eventually started exploring tactile art and how we might convey some of these concepts tactilely with the 3D printer. On the screen here, we have a few examples. I should say everything I'm showing today are my designs or things that I have printed, unless I'll note otherwise. There is in the top right corner of the slide an image of a Picasso piece. This is kind of a cubist piece, so everything's kind of, the 3D is kind of flattened down into a 2D, which is pretty fitting for today's presentation. Below that is a tactile map of the Portland Community College Sylvania campus in kind of high contrast colors. Next to that are a couple Escher pieces. One is a kind of tessellating pattern. It's the circle limit with the bats and the angels. And the one next to it is a mosaic piece. So it's a bunch of different kind of animal shapes fitted together. And then finally, there's a final tactile map in the bottom left corner that is all one color. That is another Portland Community College campus from when I was working there. So after I had kind of been introduced to 3D printing and started to kind of wrap my head around how I might utilize this in my own practice, in 2018, I was hired to work as a research assistant on a project at Portland State University. It was a collaboration between Portland State University's Visually Impaired Learner Program, which trains teachers of the visually impaired, and Cornell Tech and some of their kind of like computer technology graduate students. And so as a part of that project, we made a series of tactile maps, kind of utilizing this similar approach that I had been doing for my embossed graphics, and really kind of exploring what can we do with these tactile maps? How do we leverage the capability of 3D printers? And this is where I really started to explore exaggerating key features and kind of really leveraging that kind of third dimension that's not available to us when we're creating traditional raised line drawings. This is also when I really started to lean into this workflow with scalable vector graphics, or SVG files. Those are common from graphic design programs like Adobe Illustrator. And I think initially I was worried that this approach was going to be kind of limiting, but as I continued work on this research project with PSU and Cornell Tech, it seemed like there are actually a lot of benefits to this, and it was kind of a low barrier for entry. So I didn't have to really learn all the complexities of 3D modeling. I was able to kind of take my traditional approach and just bring it over into this 3D world. One of the kind of key takeaways I had from this experience, in the top left corner, there's a map of a travel map. So this was a adult student's path of travel from a bus stop to his place of work. And the student had been really struggling to learn this route for a long time, and his orientation mobility instructor had tried a lot of different things to help him memorize this route, and it wasn't sticking. And when we sat down with this map, it seemed like a lot of it clicked for him. So one of the key things that he said as he was exploring the map was, it feels like all the important things are just kind of jumping out at me. And that really stuck with me. I was like, yeah, that is kind of what I want to do in the best applications of this approach. I think these kind of key details should be kind of jumping out at you, so they're quick to find, quick to interpret. One other thing I should add about, so these were interactive. All of these maps were paired with an iPad application that would track your finger movement around the graphics, and it would read some audio annotations to you as you explored the graphic. So after doing some work on this project, I started to kind of get a bit more comfortable in this SVG approach and how I could leverage this for 3D models. And in the following year, I was asked to make a large-scale tactile map for Portland State University. So that's what's up on screen here. This map has a high contrast print layer that's mounted beneath some clear acrylic that's been laser cut and etched to show things like streets and bus stops and green areas, lots of different elements here. And then there are 3D printed pieces to label the tops of buildings, to label bus stops, to label streets, all of those kinds of things. So this was a super exciting project. There were so many elements happening here. And this, for me, I think kind of solidified that where I had previously been concerned of the limitations of my approach. After completing this PSU map, I really felt like, okay, I really can take this kind of simple design style and extend it pretty far to do something that is complex and still meaningful for readers. And then that brings us to 2020 during the pandemic. So I was still working at Portland Community College at the time, and we had a blind student taking an art history course. And so we're all remote. I had a small team of staff that I had trained on creating traditional raised line drawings. And so with them, we were producing just tons and tons of tactile graphics, raised line tactile graphics, and writing lots and lots of image descriptions. And then to supplement those more traditional approaches, we were 3D printing some models from the Scan the World collection. And if you're not familiar with that, the Scan the World project is on My Mini Factory, and it is a collection of models from museums around the world where the museums have done 3D scans, really high quality 3D scans of pieces in their collection, primarily sculptures. And so I was really excited. We sent this out to the student, and one of the things I heard back from the student as we were working on analyzing these pieces is that they really struggled with interpreting these complex 3D models. And I think that was kind of an aha moment for me. I think a lot of times we think, blind learners are kind of used to exploring 3D things in their everyday life, and sometimes I think we can be a little overzealous in the models that we provide to students and expect them to make meaning out of. And so this was a moment for me where I had to kind of pause and think, okay, well, these are these really beautiful 3D models, really rich with information, but how usable are these? And are these adequate in and of themselves to be learning materials for blind students? And I was thinking back to the work I did with the Sensibles project with Portland State and Cornell, and thinking about how can I take this information and kind of layer things in a strategic way so that it's easier to interpret foreground and background and key details and little embellishments so that you can kind of more readily make sense of all these things and they don't just blur together. And so I started kind of exploring that concept on my own, and I started making lots of stuff. I should describe some of the images on the previous slide. These 3D models we presented for the art history student. There's a bust of Nefertiti on the slide. There's a small replica of Stonehenge. And then the most difficult one for the student to interpret was in the top right corner of this slide, Laocoon and his sons. So this is kind of a large male figure with two smaller male figures on either side of him, and they're all wrapped up in a large serpent. And there's just a whole lot going on in this 3D model, and that one was one of the harder ones for the student to work with. So as I began exploring how I could simplify these things and how I could kind of strategically layer tactile elements to aid in interpreting these things, I started working more with some maps. I started working a bit more with abstract art. So on the left side of this slide, I have some abstract art. So there's Dancers by Theo von Doesburg. Below that, there is a piece from Wassily Kandinsky from his Klang collection. There's a piece below that by my wife. And then to the right, in the center, there is a big cat with kind of radiating waves out in a rainbow of colors. That's by Louis Wayne. And so that's some of the artwork I started kind of exploring. These are all kind of different layers or raised to different colors or raised to different heights to kind of separate these tactile elements, kind of a simple exploration of this approach. On the right side of the slide, I have some tactile maps that I created for a fully virtual tour of the Fort Vancouver Historical Park in Vancouver, Washington. And we have things like the blacksmith shop with anvils and furnaces. There's a fur tanning room with piles of furs and like a wall of hay on one side and a wagon wheel. There's a bakery below with cutout of the ovens and the tile in front of the ovens and a basic layout of the workspace. And then there's a tactile map of the garden there at Fort Vancouver. And then finally, I have some kind of loose ends. I have some little tiny mini brailers here for Barbies and for other toys. And I have a phone magnifier stand. You can put your phone in there and use it as a magnifier. And then finally, there is a spiral galaxy image that we'll explore a little bit later. So I gave a presentation this fall, this spring, that was titled 3D Printing Wrong to Create Expert Tactile Graphics. And that is a critique that's been leveled against me that maybe I'm not 3D printing correctly if I'm not fully utilizing the third dimension in my printer and creating truly 3D things. But I don't really miss it. I like this 2.5D approach. So not quite flat 2D, but this kind of exaggerated 2D where you're able to kind of raise things up, but we're not expecting the learner to really interpret everything in a three-dimensional way. And one of the things I really appreciate about this is it is very similar to the graphic style that learners are traditionally presented with. So those raised line drawings. A lot of the interpretation of these graphics kind of follows or utilizes the same skills we would be utilizing in interpreting traditional tactile graphics. So I kind of liked that idea of I'm not really trying to reinvent the wheel here. I'm not trying to bring in a new technology for the purpose of utilizing new technology. I'm kind of taking a traditional method and just kind of extending it a bit by doing this 2.5D approach. And that led me to my most recent project. In the summer of last year, I was approached by the Portland Art Museum here in Portland, Oregon, to create a small tactile exhibit for them. This was based on the Please Touch exhibit by the Musée Fabre in France, or at least inspired by it, and they provided us with some of the funding. So after lots of discussion, we landed on 4 pieces. And on the right side of the slide, there are some details of those pieces. So there's a close-up of a rectangle with kind of a really subtle texture on it. And there's a close-up of a watermelon piece with the bite taken out of the top. And there's a close-up of a water scene with a kind of plant in focus. So you can see the plant raised above the waves in the background. We'll take a closer look at these pieces here. So the 4 pieces we landed on were Wait and See 1312 by F&D Cartier. The original piece is photographic paper that had expired and created these kind of subtle colors with very kind of subtle marring on the face of those rectangles. So there's 3 rectangles mounted side by side on a white background. And my 3D model is very similar, 3 rectangles side by side. The rectangles are kind of slightly taller than one another to kind of indicate that, like, okay, these do have some differences. And then there are some very subtle textures applied to the surface to kind of give the reader that effect of when they examine this, kind of like, well, there's not anything really distinct happening there, but I can tell there's something kind of subtly happening on the face of this image. Another piece we did was Ox, or Water, by Carrie Morgan. This is a very beautiful painting. It's huge, it's like 4 feet by 4 feet, and it depicts this kind of giant swirling wave. So there's kind of a large wave coming over the top in the top left corner and then cutting through the center of the image. There's another kind of broader wave that's coming through, and then there's a small kind of spiral wave in the bottom right corner. And all of this is painted on top of a piece of wood. So you can see kind of the swirling wood pattern beneath all of this. And in my tactile version, all of these same elements are here. There's kind of a dark blue that's raised up above everything else. And there's a light blue that's kind of just below that. So the wave itself is kind of one big cohesive element, but you can see where the kind of light and dark take over from each other. And then beneath all of that, there's a wood pattern where we can see the kind of grain of the wood. We're getting close to time, so I'm going to speed things up here. We have a watermelon portrait. This one was really fun. So the original is a watermelon with two large seeds. There's a bite taken out of the top, and below the watermelon, it reads liberation. And when I was creating my version, I knew that if I just mounted this flat, you wouldn't get the same kind of experience as the original, where the original shows the watermelon from kind of an angle. So instead of mounting this flat on my page, I mounted it on a wedge so that the reader is kind of drawn towards the edge to explore that edge and really kind of get this idea that we're viewing this at an angle and not kind of straight on. So it's not a flat 2D image. And then finally, Monstro the Whale, which is one of my favorites. The original is a tapestry with kind of a frilled border. And at the center of it is this large oval water scene with a big red whale at the center. And in the background, there are these waves kind of cutting through the middle with the plant we described earlier. And so there are lots and lots of kind of tactile layers here, but because of the varying heights of all the different features, it's easy to quickly identify what's the key feature of this piece, what's in the foreground, what's in the background, how do these kind of visually relate to each other. So this is one I was very excited about. Wrapping things up, so 3D STEM. I have done quite a bit of printing for 3D STEM, and these are great. You can have lots of great 3D models for STEM learners, but you should always be considering the complexity of these models and how easy it will be for your learners to interpret these, and what can you do to support them interpreting these models. So some examples I have on here is the frog dissection kit that's really popular on Thingiverse. We have a model below that of the female reproductive system, which has been really helpful for some of our students. There's an animal cell model. None of these are my designs, but they're all my prints, except for this final one is an anatomical model showing muscle structures on one side and skeletal structures on the other. And this was 3D printed for us by C3D. Finally, 2.5D does work great for STEM as well. But some approaches, some images are going to work better for this approach than others. I have some examples here that are all done with basically lithophanes. So this is a technique that will do kind of a grayscale height map of an image and produce these kind of nice tactile models. So not everything is going to work with this approach, but some images do work really well. And a lot of times I end up kind of augmenting these. So some examples I have here, there's craters on the moon with some braille labels. To the right of that, this is muscle tissue in people with and without muscular dystrophy, comparing those. That's in the top right corner. There's a kind of lunar phase model showing all the different patterns of the moon. And then finally, there are these spiral galaxy models. And these spiral galaxy models went through the kind of traditional lithophane approach, and then I took them into a modeling program and exaggerated all the different features so that it's easier to see how the spirals varied between these different models. So not just kind of taking what was spit out from the lithophane approach, but augmenting it to further enhance these features. So my pitch for today is that 3D printed graphics are really great for complex topics, but you have to be really careful when you're designing these or you're thinking about how they're being presented. And 2.5D graphics, these kind of flat but exaggerated graphics, have lots of benefits. So it's a tactile style that's familiar to blind readers that are used to seeing things in this kind of flat tactile style. You can exaggerate features to make them easier to locate and interpret. You can add lots of layers to convey a lot more information than you'd be able to fit in a traditional 2D graphic. This workflow is really similar to the traditional graphic style, and it's much easier to apply existing tactile graphic standards like those published by the Braille Authority of North America. Okay, that is the end. We made it with just a bit of time for questions. My contact information is on the screen. You can go to www.mcantino.com, MCANTINO, to see more of my work.
Michael, thank you so much for that fantastic presentation. We do have quite a few questions for you, so we'll try to get through as many as we can in the next few minutes here. The first is from Thomas Madura, who says, have you thought of using AI to help generate 3D printable 2.5D and raised tactile models from images to streamline the process and help make things faster?
I haven't had much success yet. So if anybody has tips for that, let me know. I have made several attempts to take complex images and run them through AI to create just simple raised line drawings or just line drawings. And I've had limited success so far. I think a lot of times what's kind of a key thing in creating tactile works is you really need to simplify key features, and I don't see AI doing that well for me currently. It likes to include a lot of detail.
Thank you. The next question is from Joanne, who says, we teach a variety of STEM topics. So what is the best way for teachers to access models to use with students with visual impairments or to make quickly at a low cost? Is there a checkout library somewhere? We use WikiSticks and modeling clay, but any other ideas?
WikiSticks and modeling clay are great. For 3D models, there are the big repositories like Thingiverse. There are things like Yegi, where you can search multiple repositories in one go. Tactiles.eu is a great one that's specifically for blind learners. APH has some has their Tactile Graphics image library for raised line drawings. They have some 3D models there. But I think the kind of best way is if you can create your own. I think the more I get into 3D printing, the more I am reluctant to work with other people's models. It's being able to custom make your own designs really goes a long way. And using SVGs, you can get there pretty quickly. So I didn't discuss that process today, but it is fairly simple. And I have some of that process posted on my website.
Fantastic. And I think that actually leads well into the next presentation, which will be about C3D's work on 3D printing as another resource for being able to access models. Final question here. We have some discussion around the moon phases. Jake asks, did you test the moon phases with blind users, and could they appreciate the cratering?
This was one that was really just an experiment, and I haven't put it in front of learners, but that was kind of the objective. And my kind of theory with this is that I think when we think about tactile objects, I think people have a tendency to overestimate how much learners are going to be able to interpret. And so when we think about the cratering in the image that I shared, it's not that learners are going to really get a nuanced view of all the craters on the moon, but that they'll start to get some understanding of kind of how intense the cratering is, how consistent it is across the face of the moon. Those kinds of kind of broader gestalt of that. And so whereas if you kind of present that in a traditional embossed graphic, a lot of that's going to get blurry and kind of fall by the wayside. And you're really just going to be exploring the kind of waxing and waning. So this wasn't one I was able to test with end users, but that is my theory. And I think underlined by some of my other work, I would expect that it would work better than raised line drawings and conveying that information.
And to that point, I see here that Tom commented that his team has also done some testing with moon phases and craters, and students were able to appreciate the cratering, especially if the data is a little bit exaggerated there. So thank you, Tom, for that addition. Great. Michael, thank you so much for your presentation and for sharing this great work with us today.
Thanks for having me.
SciAccess. Learn more at www.sciaccess.org.